Hi, today I'm going to go through a PAT paper in 2016 looking at question 20. Okay, so we're given this, in question 20 we're given this layout here, and we're told that each resistor has resistance 12 ohms, and that we have circular water heaters of resistance 6 ohms. And we're told that each water heater contains water at 1 kilogram of water at 20 degrees Celsius. We asked how long will it take to heat the water to 27 degrees Celsius? How long will each heater take? We have an 84 volt input here. Okay, so how do we start this? Well, we know that the energy required to heat a fluid up is Q equals mc delta T, where delta T is its change in temperature, C is the heat capacity, and m is the mass. We also know that energy is equal to power times time. So if we can find the power dissipated across each heater, we can find the time it requires to get this energy, and therefore the time it takes to heat the water up. Okay, so let's think about this. Well, we have 84 volts and we have 3 parallel wires. So we're going to have 84 volts across here, 84 volts across here, 84 volts across here. But we have two identical components in series along here. So what that means is, well, their voltage is going to split evenly. So we're going to lose 42 volts across here and lose 42 volts across here. So that means the potential difference here is going to be 42 volts, because we're losing 42 volts across here, exactly half of the voltage. But similarly, these two components are in series. So we have 42 volts across here and 42 volts across here. Well, let's think about this. What that means is we have a potential difference of 42 volts here and a potential difference of 42 volts here. So that means the difference between these 2 points is actually 0 volts. And so no current will flow through A. So now we can simply use our formula, that P is equal to V squared over R, to find the power dissipated across each heater B and C. And we notice they're identical. So we notice that PB equals PC, which is V squared over R. So that's 42 squared over the resistance 6 ohms. Well, that's 7 squared times 6 squared over 6, which is equal to 7 times 42, or 294 watts. Well, therefore, that the power times time we know power times time is energy. So how much energy is required to heat the water up? We know Q is mc delta T, so the mass is 1 kilogram, times the heat capacity 4,200, times change in temperature is from 20 to 27 degrees, that's 7 degrees. So that's 4,200 times 7 joules. So we require that for some time t, we know power times time is energy, so it's going to flow for some time t, and we require that to be equal to 4,200 times 7. Well, therefore we want 294 t to be equal to 4,200 times 7. Well, we know 294 t is 7 times 42, so we can cancel off the 7s and get that therefore 42t is equal to 4,200, or t is equal to 100 seconds. So this means that heater B and C take 100 seconds. And then A, well, what about A? A has no current flowing through it at all. And so it will actually never be able to heat the water up. So A will never heat the water. And that is our answer.